Hello and good morning. My name is Muhammad Iwan Nasri. I will present about smart waste classifier. So the introduction is our project is artificial intelligence, especially convolutional neural network (CNN) to recognize different type waste through the webcam and classify them into the correct category. So move on to the second slide. Nowadays, waste segregation is still major challenge. Around 30 to 40% of recyclable waste become contaminated because people throw item into the wrong bin. In addition, approximately 80% of users are unsure how to sort waste correctly. The main reason is there to know quick and easy tool and that tell user where an item should be disposed. So next slide is proposed solution. To solve this problem, we develop the smart waste classifier. This is a lightweight web-based AI application that use a webcam to recognize waste item in real time. The process is very simple. First, the webcam captures an image of the waste item. Next, a CNN model trains user using Google Teachable Machine analyze the image directly in the browser to the TensorFlow.js. Finally, the system predict whether the item belongs to the plastic, paper, or organic category. So next, we go to next slide, system workflow. This slide show the overall workflow for our system. There are 5 steps. First, the user place the waste item in the front of the webcam. Second, the capture is pre-processed by resizing it, normalizing it, the pixel value, and applying data argumentation if needed. Third, the processed image is sent to CNN model for prediction. Fourth, the softmax layer calculate the probability each waste category. And finally, the last is the system display the predicted category along with its confidence level of on the screen. So the last part is methodology. Now let's move on to the methodology. The first stage is data acquisition. We collected our own image of plastic, paper, and organic waste under different lighting condition, viewing angle, and background. The second stage is pre-processing. Before the training, all images were resized to the required CNN input size. We also normalize the pixel value and apply data augmentation technique such as rotation, flipping, brightness adjustment. So the third stage is model training. We use Google Teachable Machine to train our CNN model. During prediction, the model use softmax function to calculate probability of each waste category and then select the category with the highest probability. The final is deployment. After training, the model was exposed in TensorFlow.js format, integrate into a web application, allowing user to classify items directly in the browser without needing a server. That's all from me. Thank you.
I will now continue my friend's presentation on the CNN architecture. So this is the feature extraction and up until the classification, as you can see from the graph here, from the table over here. So now I would like to continue with tools and technology that we use on our project. The first one is we use a teachable machine, and the second one is we use a webcam API for the webcam on the trash can, and then we use PowerPoint and Canva for presentation, system design diagrams, and project deliverable materials. Okay, and then lastly we use TensorFlow.js. This is for running the coding in browser client side. Enables real-time, low latency classification with no backend server. Next, this graph shows the expected result for our per class accuracy targets. So in our project we have 3 classes, which is plastic, paper, and organic. So real-time interference latency is less than 2 seconds, and the minimum accuracy threshold for our project is more or equal to 80%. Next, I would like to talk about the limitations and future work for our project. So the current limitations is that we have a small team, collected dataset, and limited variety. Next, we also have a 3-class scheme only. We have no glass, no e-waste, or nor metal. Okay, next one, we do not have composite items such as laminated curtains. This will let our program sometimes misclassify it into the wrong classes. And lastly, we require a webcam equipped device on each our trash can to make it more accurate. So for future directions, we are planning to expand the dataset with more items and lighting conditions. We are gonna add glass, metal, and e-waste categories, and then we are going to integrate with a physical smart bin, and we are planning to make a mobile app deployment, whether on iOS or Android. Lastly, I would like to go through our conclusion of this project. So firstly, our project will have a real-time AI classification of plastic, paper, and organic waste via webcam. And it is also CNN trained with teachable machine, deployed browser site via tensorflow.js, and it is zero cost with no server. And then we have a target accuracy of more than or equal to 80%. So we have an instant feedback to form correct disposal habits. Lastly, we should all support UN SDG 12, responsible consumption and production. That's all from me. Thank you.
Okay, S1G2. So as S19 is proposal is about manage waste. We have this plastic, paper, and organic, the teachable machine to give them samples for them to learn what type of waste will it be. So, for example, like this one, look at the result. It will show paper. So, and yes, this is paper correct. And like this, for example, this is plastic, a bottle, which is plastic, and as the result, it shows 100%, which is correct. Other than that, like this one, this is plastic too, a bottle, a water bottle, which is plastic, and the result is correct. And like this one too. Now, this is probably a plastic too, and I think that's all that I can show how this works. This is a paper, and this is how the machine learn about this. I think that's all.